Hello everyone. Today we're going to talk about JWT tampering, JSON Web Token tampering. And we're going to also demonstrate how you can actually tamper with the JWT authentication if it's not configured correctly, if the implementation is wrong. Even if you're using the right algorithm, it can actually go very bad for you. And this is a demo where I'm going to show that you can take over an admin account from a regular account. Now, today we're diving, like I said, on the JWT tampering. The first thing is, what is JWT? As you all know it, JSON Web Token. It's just a compact, self-contained way to transmit information from one application to another. Or basically, when a user authenticates, they log in using the username and password. That information is contained and transmitted using JSON Web Token. And here's what happens when the user logs in. The server verifies the credentials, and the server generates what's called JWT signed JWT token. Now the server sends this JWT token back to the client, and we're going to see it on the demo. And then the client, each time the client requests some access, let's say some internal page or something, it would actually add as part of the header this JWT token. And now there's two ways to do it. Sometimes in my design, the way it is actually the JWT token is part of the cookie. It's stored in a cookie, and each time the application allows access to a certain part of the application, like internal application or maybe allowing an API or something, it would check the cookie and find the JWT token and verify that it is actually not expired. It has the signature is good. Yeah, so that's how it is implemented. The second way to implement it is actually you can add it as a header called authorization. And the value will be called bearer, and you're going to add the JWT token next to it. That's another way to kind of send request to the server. So the server can actually verify the JWT token and actually allow the access. Now, let me just go over some important aspects of it. So the way a JWT token is constructed is like it has three most important parts. They are separated by dot. The first one is a header, the middle one is a payload, and the last one is signature. The way the JSON Web Token works is there's going to be some kind of algorithm depending on what you chose. Most of the time, most applications use HS256. Basically, what it does is we take the header. The header part would have two values like ALG stands for algorithm and basically states it's going to be using the H256, and TYP stands for what kind of token it is. It's just going to be JWT token. And the second part is basically the payload. The payload has information like SUB, which stands for subject, IAT, issue time, EXP is just expiration, and sometimes some not very common, but you can include headers like AUD, which stands for audience, and also ISS. So, and also you can include my application implementation for PinewoodStore. I include an implementation called rows. Rows is going to be part of the payload. And the last part of it is just a signature. The way the signature is constructed is now the header and the payload are they're not encrypted. Basically, what's going to happen is going to be base 64 encoded. The header and the payload are going to be base 64 encoded. This is typical example of a header. The algorithms are on HS256 and type JWT. And another example of a payload would be this would be a good example of a payload. And so you can see like the format is just a JSON format, right? It has parentheses and key value pairs, key values, which is kind of JSON. So this would be URL encode, base 64 encoded, and also the header would be base 64 encoded. Now the algorithm would take the header and the payload that are base 64, and the algorithm has its own secret key. It will use that, and it will run through the whichever algorithm that you chose. In this case, you're just going to be HS256, and will generate the signature. So each time the authentication works is, let's say information gets sent over. If somebody tries to tamper with it, this part of the last part of the information, which is going to be the signature, is not going to be the same, obviously. Let's say if I try to, an attacker, I'm an attacker. The payload is just, the role might be just be a user. And I try to change it to, let's say, an admin. And I base64 encoded and just constructed this payloading, this JWT token again, because I can do that because this part, like I said, the header and the payload are only base64 encoded. You can do that. But the signature is what is the most important part. It would verify that nothing has been tampered with. But like I said, every implementation is everything. What we're going to see is I introduced a vulnerability where the implementation allowed the signature token, signature verification to fail, and allows uh, an attacker to tamper with it. And that's what we're going to demonstrate today. Now, common vulnerabilities you see with JWT is, one, setting the algorithm to none. If you set the algorithm to none, and I'll demonstrate that on the live demo, and send the request, and if it gets accepted, it means it's vulnerable. You can tamper with it. And the other one is just algorithm confusion. That's what it's called. If the server supports, let's say, RS-256 and HS-256 symmetric without validation, or you're not locking it to one, an attacker can forge HS-256 token using a public key as a secret. Let's say Apple has a public key and they use that, and most of the time, here's the thing, most of the time, there's no way that this is just theoretical, but most of the time, the secret keys are not going to be the public keys because public keys are accessible, right? Who's going to use a public key? And somebody else can use your public key and actually create everything. So basically, they can use a public key and construct a JWT token and see if the backend servers would accept it. Now, if it is vulnerable, it could create what's called algorithm confusion and might allow the authentication go through. The other one is ignored expiration. So as you can see here, like I said, the header, the payload has multiple parts, and some of the parts is IAT So this is Unix time. You can actually go look up a Unix time and online. We can just look at it. A Unix time converter. So let's say this is one Unix time. What we're gonna do, I'm gonna go ahead. Once I generate this, I'll come back and I'll show you. I can actually generate this. You can put, let's say it gives you this example, right? And you can just say convert. This is what it stands for. But I can also do this 2024 convert and put this Unix time, which is in the past, and try to see if I can tamper with who's authentication. Basically, because if somebody can actually do this, what that means is they could use a token that has been expired. So that's another vulnerability, and somebody can log in. So with that being said, this is my blog. Every detail has been explained, including my source code that I used, and I'm gonna share the link on the video. But let's go ahead and start the demo, the PinewoodStore vulnerable application. So this is what I'm gonna do. First thing, just to show this is actually JWT token tampering. We're gonna use two accounts. Well, actually, technically, we're gonna use one account. As you can see here, there is an account called JBond. And as a matter of fact, we don't even have to do that. We can start from scratch. Let's go ahead and register a new user. Let's call it test user 1. All right, we created test user. And as you can see here, there's register and everything's good. I didn't get any errors, so let me go ahead and clear this so we can see what's gonna happen next. So I'm logging in now. All right, this is our test user. Currently, he doesn't have any name, so let's give him some name. Jack. Let's give him 36. So as you can see, this is a regular user account. So let's try to see if we can get the username. Obviously, we can't change that once we log in. The rest of the information is what we changing. So I'm gonna go ahead and log out. I don't even have to log out. I can just clear everything here. Let me refresh this. This is the internal page. So what we talked about earlier on, a user logs in, types in the username and password. The server authenticates. The server generates what's called JWT token. Now, each time you access an internal page, which in this case is welcome, what the application does is it would expect this token. And based on this token, after verifying the token is valid by checking the signature, the expiration, and all that stuff, and it would actually allow access. So basically, when I send it, this is actually welcome. It's basically saying I'm logged in as a current user, which is a user we created. So we can actually see his name here. As you can see, welcome Jack. So now the first thing is let's take a look at the JWT token. Like we talked about earlier, it's made up of three parts. The first part separated by period. The first part, which is a header, which shows ALG and HS256. Basically means the algorithm, and the algorithm being used is HS256. The second part is the payload. The payload contains information about, a lot of the times, contains information about the application, roles, usernames. So in this case, username, role, and the user is a regular user, so it's gonna have a role user, and the username that we create. SUB stands for subject, so it's gonna be test user one. IAT stands for issued at, and EXP stands for expiration. Now we can tamper with a lot of things, but the most useful thing that would be for an attacker would be to gain access to an account takeover, right? So let's try to see if we can take over another account. Let's try to see if we can take over an admin account in this case. So we do have one admin account, this one. Let's try to see if we can take that over. Now, if JWT token tampering works, what's going to happen is when I tamper with this payload, the application is going to validate this part of uh, the JWT token, which is going to be a signature, is not going to match, and it has to drop it. It was 401. But this application is made intentionally vulnerable just to show what could happen if you don't implement your code right. So let me go ahead, change this. And base 64 encoded. Now it's a new request. Let me go ahead and actually send it to another tab. And send it. And I have 200 OK. And as you can see here, I can scroll down. I'll also copy it to the browser. But if you see here, it does have admin. And also, if we look at the name, right now it's actually Adrian. So let's go ahead and see it on the browser. Copy the origins. And mind you, this is actually a regular user, right? Tampered with. So that's it. So I'm logged in right now as an admin user, which is Adrian Chapa, admin, his first name and last name, and I can do anything. It just basically shows how an account takeover happens when you don't have your JSON Web Token implemented correctly. So I have shared detailed information on my blog post, which I'm gonna link on my video on this video. So that's it. That's what I have for today. Thank you.